Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be on page number 174. We're going to be talking about functions, and this is a topic that we kind of touched really briefly in Algebra 1, but we are going to spend quite a bit of time on it here in Algebra 2. This is actually one of the main topics that will carry over with us into pre-calculus. So this is an important topic for you to know, especially if you're going on to pre-calculus. If not, it is important that you understand it. So make sure that you try to pay attention. It is a challenging concept, but one that I think with a little bit of work we can master pretty quickly. All right, so if you look down here on page 174, I have something on the screen as well. It says that a function gives exactly one output. Okay, in other words, when you input something, we just worked with inverse and with direct variation. And when we input something, when we put something in, it would give us something out. We'd put an input and it would give us an output. Well, the same thing is going on here with functions. Um, and the direct and inverse formula is a function, okay? Because you put in one input and you get one output. Notice it says it gives you exactly one only. You say, well, what happens if I get two answers? Then it's not a function. What happens if I get three, four, five answers? It's not a function. It only if you get one answer. All right. And what do I mean by that? Well, here's an example. In direct variation, when we had y equals kx, okay, when we put something in for x, x is the input. Let's say we said x equals 6 and k equals 2. Well, when we get our output, our y, so y equals 2 times 6, we get y equals 12. We get one output, only one answer, okay? For every input you put in, you get one output. Now, let me show it to you where it gives you two outputs. Let me show you. So this one, the one that I just did, would be a function. This one that I'm going to do now is not going to be a function. So let's say we had y squared equals 16. Let's say y squared equals x, and we said that x equals 16. So our input is 16, okay? So we input that and we get y squared equals 16. Well, when we square root both sides, we get y, because that's going to cancel, equals, remember we have a plus minus over here because we have to square root both sides, and then the answer would be 4. Notice that we get y equals plus minus 4. That plus and minus, that's two answers, okay? That's a plus 4 and a negative 4. And so this would not be a function, okay? When you get two answers, two outputs, it is not an answer. So if you get two y's, three y's, four y's, however many y answers you get, it is not a function if you get more than one. When you do get one, only one, function. Okay? All right. Some ways that functions can be expressed. What does the word expressed mean? Well, expressed means to like say something, to write something, to communicate something. So how can we communicate functions, or how are they communicated with us? How are we going to see functions? Well, the first one is verbally or with words. This could be written too. You could write out the function using words. Sometimes somebody would just say something to you that is a function. They don't maybe even know that it's a function. They're saying, well, if Bob works at the factory and if Bob works for 5 hours, he makes 20 t-shirts. Okay? Well, that's a function. We can plug in things and they don't even know they're telling you a function, but they are. And so functions can be expressed verbally or with words. Another way that you can express them, and this is on page 175, if you're following along in the book, you can turn the page. The second way is with ordered pairs. ordered pairs. I wrote down X and Y, okay? X and Y. You remember those from graphing, right? So you have the X coordinate, the X axis and the Y axis, and so the X coordinate point is right there, and you'd move on the X back and forth, right? And then the Y coordinate is right there, and so that one would be the one that you go up and down with. You remember that? It was just last chapter, I believe. Okay, and so you can call them coordinate or ordered pairs or coordinate points. Okay. The third way that you can express a function is graphically. Basically, it's the same thing as the ordered pair, except for now they're not giving you the ordered pair. Now they're just showing you the graph. What do I mean by that? Well, they actually give you a graph and they put 2 points there, something like that. Okay, so you could show a function by actually graphing it, putting it onto a piece of graph paper. The fourth way to show a function is algebraically. Now, if you've been paying attention, hopefully you have, you know that the name of this class is algebra. Some of you are like, what? I'm in the wrong class. No, algebra, algebraic. So this is going to be one that we're going to focus on a whole bunch, okay, because it's algebra class. And we're going to do a lot of these algebraic functions. We'll be doing some of the other ones. The one that we're going to deal with the least is the verbal ones. If they give them to us verbally, we're going to actually put them into algebra or put them into an ordered pair or put them into a graph. But we can receive them verbally, but then we have to do things with them to solve them. Ordered pair, graphic, and algebraic. Those are the 4 ways that we can express or communicate functions with each other. Okay. Now I want to go back over these bottom 3. These are the ones that I want to focus on in today's class. And I want to talk about each one, and I want to talk about how do you know if it is a function or if it's not a function. So if we go back up here, I showed you where if we take this right here, we find out that it's not a function, right? This is algebra. I don't know if you're familiar with algebra or not, but that's algebra right there. So if I have an x and a y and squareds and square roots and all these other things and equal signs, this is algebra. So I expressed this function, it's not a function, but I expressed this expression as in using algebra, okay? So when I figured it out, when I solved it, it gave us 2 answers, and we know that that is not a function. So on these ones down here, algebraically, the way that we know if it's a function or not is we just figure it out. We just solve it. And when we solve it, if it has 1 answer, function. If it has 2 answers, not a function. Okay. Now let me talk about these 2, ordered pair and graphic. How are we going to tell if it's graphically, if they give it to us in a graph, how are we going to tell? And I'll kind of go backwards from this. So I started with algebraically. This one is graphically. How do I tell if it's a function, if it's expressed graphically? Well, we use what's called the vertical line test. The vertical line test. Okay. Now, let me show you what I mean by that. And I'll just draw a real simple graph here. It won't be anything special. Not going to draw it on graph paper or anything. And I have, let's say we have a parabola. Okay, we've already worked with parabolas a little bit in Algebra 1, and then I think we've talked about it a little bit this year as well. But let's say that we have a parabola on this. And let me change the color so you can see it a little bit better. Okay, so we have a parabola. Now, if we use the vertical line test, here's the vertical line test. I can put a vertical line anywhere on the graph, vertical, up and down, okay? Basically, the y-axis is a vertical line. So I can put one anywhere I want, okay? In fact, we're going to put multiple ones. We're just going to look at them. So I'm just kind of drawing multiple ones, different places, so you can get an idea of what I mean. Now, here's the vertical line test. If the parabola, or if the line, whatever it is, touches the vertical line more than one time. Okay, so let's go back up to our definition of a function. Gives exactly one output. Okay, so if it touches the line exactly one time, then it is a function. Okay, so there we go. How many times does that touch? One time right here. Okay, so it touched one time. Function. Okay. Vertical line here, it touches one time. And you might say, well, but if I put one here, it doesn't touch at all. Well, it actually does, believe it or not, because if you know anything about parabolas, you know that this line right here that I drew, excuse me, it keeps doing that. There we go. It just keeps going and going and going up and up and up into infinity. And so if we could draw that line up into infinity, it would eventually touch your parabola. It would. So put your line somewhere inside the parabola so you at least get it to touch once. Okay? And then that's the question, the vertical line test. Does it touch? Now, sometimes in algebra we get parabolas that go this way. Okay, and I'm trying to draw a parabola. They're not perfect, but there's a parabola. Now, if I draw my vertical line on this one, what happens? That's right, I have 2 points. Okay? 2 intersection points. I got one there, and I've got one there. Well, there's a problem. I can't have it touch the line more than once because we go back up to the definition of a function. If it gives you exactly one output, and if it's touching the line twice, then it's not giving you more. It's giving you more than one. Okay, so if I put my vertical line on there, and it touches it twice, this is not a function. Okay, this one would be a function if it goes up like this, because then when I put my line on it, it only touches once. The ones that go like this, because it's going to touch the line twice, not a function. Okay, and you could also know that maybe you have something that looks like this. Okay, you'll get to that when we get to pre-calculus. Well, you put your vertical line, it only touches the vertical line once. Okay, it's still a function. Now, what happens if my wave is going like this? Well, once I put my vertical line on there, it touches it multiple times. This one touches 3 times, 4 times. Definitely not a function. And that goes with any type of a line, okay? If that's what your graph looks like, you put your vertical line. Yes, it only touches it once. But then you might have one that kind of goes something like this. Whatever the line does. Lines can do weird things on the graph. Well, yes, it touches it more than once. Okay? So that's the vertical line test. How many times does it touch the line? Once, function. Twice or more, no function. The last one is ordered pairs. I said I was going to go backwards on this. Ordered pairs. All right, so here's the trick with ordered pairs. If you get different outputs, and I'll write this, I'll abbreviate outputs. What's the output? Do you remember? Okay, I showed you in the last video. The output is the y. So if you get different y's, different values for y's, when you have the same input. And what is the input? Okay, the input is your x. Okay, so in other words, if you have the same x and you have a different y, then it's not a function. Okay, so different outputs for y when you have the same input, this would be no function. Okay, what do I mean by that? Let me show you one. Okay, so let's say that I have -1, -1. That's my first coordinate point. My second coordinate point is 0, comma, -1. So let's talk about that. So we have, look what we have. We have different inputs, but we have the same output. Well, that's fine. That's not a big deal. But watch what happens if I do this. Same input, different output. Now, let's go back and look at this. Different outputs when you have the same input. So if I have the same x, look at here, I have the same x. That one, x equals -1, and the other one, x equals -1. But look, so this is our x, and this is our y. Notice that my output is different. My y term is different. Because the output is different, this would be no function. No function. Okay, so let's say that I have this. I could do this. This would be fine. If I have -1, -1, well, that's the same input, same output. That's fine. What we can't have is same input, different output. Okay, so let me draw like just a few of these. I'll just string together some of these. 2, comma, -1, 3, comma, 0, -1, comma, -1, 4, comma, 6. And so the question is that a function or is that not a function? Okay, so we're looking at all these different ones. All right, so you need to isolate the inputs. So there's some different inputs. Now, notice that we only have the same input once. The same input happens. Here's the question. Do we have the same output? And the answer is yes. So it's okay. This is a function. What happens if I'm drawing this, or if I get this list and this is different? Let's say this is a +1. Notice that I have the same input, the same x, but I have different outputs. My y changes. So is that a function? The answer is no, that is not a function. Okay? All right. Well, that is the lesson for today. Basically, today you're going to be identifying function yes or no. If it is a function, then it has one output. If it's not a function, then it has two or more outputs, two or more y values, if you will. Okay? All right, hope you learned something. If you missed anything in there, you can always just rewind that video real quick and make sure that you can understand this whole lesson so that you can do these things moving forward. Quizzes, tests, homework, all that stuff that you got coming up, okay? All right, hope you have a good rest of the day. We'll see you later. Bye-bye.